Hello, Honors Pre-Calc. Welcome to section 5.3. We're skipping 5.2 just because it's harder to do virtually and it's not as important. So we're moving on to something that's hopefully slightly simpler just because it's solving an equation, and that's something we already know how to do. So we're going to be solving trig equations, and there's 3 examples that I'm working through in 5.3, and I'm working through them just from your book. So this is the first example. We're going to solve this equation involving tangent of x, and we are solving for x. We want to know what value of x, right, what radian measure on the unit circle makes this true. So we have to isolate the trig expression, right? There's no tangent squared, there's nothing like that. Let's just get tan x by itself, then we can figure out where on the unit circle does that work. So we first want to get tangent by itself. So the way we're going to do that is I'm going to subtract tangent from both sides. All right, when we do that, we had 2 tangents minus 1 tangent. So we are down to 1 tangent of x. Then we have a minus the square root of 3, and then on this side we have nothing, so we have 0. Now essentially we want to get tan x by itself, right? We want to isolate it. And so let's add root 3 to both sides. So we basically want to know where is the tangent of x to the square root of 3. Now, we're not just going to tan inverse both sides. We are going to be given, since we don't care if this is necessarily a function or not, we want to actually find all the spots on our unit circle where the tangent is the square root of 3. Now, I have put a unit circle on each slide of this video just for help, but I'd recommend that you just use yours, but you can totally use this one. All right, tangent is sine over cosine. So we want to know where is the sine over the cosine, the y over the x, where is that the square root of 3? So basically, it's not going to be at any of the over 4s because that does not involve square root 3's at all. So it's either a pi over 6 or a pi over 3. If you do y divided by x here, you get 1 over root 3, which is root 3 over 3, not what we want. But if you look at pi over 3, that's our winner, right? If we take the sine divided by the cosine, or y over x, we get the square root of 3. So where is the tangent square root of 3? Right here at pi over 3. Now, where else is it positive root 3? Well, it's also positive root 3 down here, where both the sine and the cosine, the y and the x, are both negative, because when we divide y divided by x here, we get a positive root 3 for our tangent. It does not work here or here at 2 pi over 3 or 5 pi over 3 because the tangent would be negative there. So the 2 spots that it works, the 2 spots where it works are pi over 3 and 4 pi over 3. Now, a couple comments about how we answer this. Since we're asked just to solve this in general, we know that the tangent repeats itself every pi, right? The period of tangent is pi. When we graphed it, tangent kept repeating itself after pi. So if we start at pi over 3 and we add a whole pi to it, we get down here to our next answer. Then the tangent is also root 3 if we add another pi to it and go back. And we can just keep going around the circle, adding pi every single time, right? Pi is half the circle. So I'm going directly across the circle, 180 degrees or pi radians more to our answer. So I could write this in a couple ways. Actually, the best way to write it is just including pi over 3 and then adding k pi. Your book might use n, I can't recall, but adding k pi, where k is an integer. This works, this encompasses this answer. Let's think about that. If we're saying every pi over 3, so every time we're here, and then every time we add an entire pi, so our first integer value is 1. So if we add 1 pi to it, I get here to 4 pi over 3. I'm adding 3/3 of a pi, so I'm ending up down here. Then let's say I started from pi over 3 and I added 2 pi. I went all the way around the circle. Well, I'm back here. So this answer works, and it encompasses this value. Now, what if you were only asked to find solutions from 0 to 2 pi? Well, then you would only have to answer this and this. You wouldn't have to keep infinitely going around the unit circle. But since we were not asked that, we are going to give our answer like this. Since, again, a circle, we can keep looping around it an infinite amount of times. Okay, this one I have as a U-try problem. Even though we haven't worked with sine yet, it's the same idea. So if you feel confident, I'd like you to just pause the video and solve. If not, then you can watch me work through it. But go ahead and pause if you'd like to try it. All right, the algebra part of this is not too bad. I went through and just got sine x by itself. So take a look at those 2 steps. So I basically want to know, where is the sine square root of 2 over 2? So if we look at our unit circle, sine is our y value. Where is the sine square root of 2 over 2? I want, positive values here. Here at pi over 4, and here at 3 pi over 4. Now sine's different. The period of sine and the period of cosine are 2 pi, as opposed to the period of tangent, which is 1 pi. So we want to include pi over 4, but then every time we go around the unit circle again, the sine is root 2 over 2 again. So we want to include pi over 4 plus every time we add 2 more pi, every single time we loop around. We want to do the same thing for 3 pi over 4, every single time we loop around. So the way that we answer that is that x can be pi over 4 plus adding 2k pi every time. We're adding 2 pi any amount of time that we want, any integer amount of time, so not like a half amount of times or anything like that. Remember that z just means k is an integer, right? A number like -2, -1, 0, 1, 2, 3, and so on. We also want to make sure that we include the 3 pi over 4 option because sine's also root 2 over 2 there. And we do the same thing. Cool. Now, if we were asked, solve this problem only from 0 to 2 pi, so only around the unit circle 1 time, all we would need to do is include these 2 values. We wouldn't need to include circling the unit circle multiple times. But these are the main 2 spots on the unit circle. A period of sine is 2 pi, so we have to make sure that every time we go around again, we include that answer. So that's what this is doing here and here. Okay, this next problem is the second example in your book. And this is one that's still isolating the trig function, but in this case, our trig function sine is squared. So we'll have to just take the square root. It's still the same algebra-based problem. We want to still isolate sine of x. So our first step, we have to remember how to solve an equation, right? We don't first divide by 4. We don't first take a square root. We want to get this term isolated first. So our first step is to subtract 1. So then we'll have 4 sine squared of x equals 3. Our next step is not to square root. Could you? Sure. That's because 4 is a perfect square. But your best bet is to first divide by 4. So we'll divide by 4. That gives us sine squared of x is 3/4. Okay, now this is telling you what to do, but it won't always be that way. It'll just say solve, right? I'm adding this extra thing here to help you out. But obviously, if we want to get sine by itself, we have to take the square root, okay? So we need to square root both sides to get sine of x by itself. And then we have sine of x equals plus or minus. We need that plus or minus there because we are taking the square root while solving an equation. So we're square rooting both sides, we need the plus or minus. Now, can we take the square root of 3? I mean, not nicely, so we're going to leave it as root 3. Can we take the square root of 4? Yeah, it's 2. 4 is a perfect square. So we'll rewrite this as plus or minus square root 3 over 2. This means that we have to include where the sign is positive root 3 over 2 and negative root 3 over 2. So we're going to have more answers for this problem because we can have positive or negative sign values. So where is the sign? Sign's y. Where is it positive square root or negative square root of 3 over 2? It looks like that's all of our pi over 3 options. Those 4. Then we have to add 2k pi to each one because not only is it just pi over 3, we have to include every time we go around the unit circle. Not only is it just 2 pi over 3, it's every time we go around the unit circle. So our answers are going to look like 4 expressions, basically 4 math phrases. So x is going to equal, the first one is pi over 3 plus 2k pi, where k is an integer. The next one is that x could equal 2 pi over 3 plus 2k pi, where k is an integer. And I'm just going to repeat this with the other 2 options where the sign is negative root 3 over 2, which is down at 4 pi over 3 plus 2k pi, again where k is an integer. And the last one is 5 pi over 3 plus 2k pi, where k is an integer. That's annoying to write out, I agree. So a lot of times I will only ask you to solve from 0 to 2 pi, and you'd only have to answer with these 4 values, since we're limiting it to one time around the unit circle. Okay, here is a you-try problem. What I'd like you to notice before you pause the video and try it is that I'm having you solve this one only on the interval from 0 to 2 pi, so you don't have to keep adding like the plus 2k pi or whatever. And then, because you're only giving answers going around the unit circle one time, notice that the interval is going to be closed on 0 and open on 2 pi. We'll discuss that more at the end. So go ahead and pause the video, solve it, see what you end up getting for your radian measures, your answers. Okay, I've gone through and solved this one. So we end up wanting to find out where is the tangent, however you want to look at it, non-rationalized or rationalized. Where is the tangent plus or minus root 3 over 3? And only on this interval. So you don't have to add the plus 2k pi or anything. So we can answer this by seeing where is our sine over cosine, where is our y over x going to give us this, basically. So that would be the case here at our pi over 6's, right? If we took the sine, 1/2, and divided it by root 3 over 2, the 2's would cancel. We'd be left with 1 over root 3, which is this. So it's basically our pi over 6 family is our answer here. And so we can just list those values. There are fancier ways if you want to write it, but we can just list those values on the unit circle. So our x values are angles that make this work. Our pi over 6, 5 pi over 6, because again, we're looking for when the tangent's positive or negative when we took the square root. Our next radian measure that works is 7 pi over 6 and 11 pi over 6. Again, we don't have to add plus 2k pi because we're only asked to find answers on this interval and not like infinitely, right? So if I started off with pi over 6 and added plus 2 pi, I would be greater than 2 pi. I would be at 13 pi over 6 here, starting here and looping all the way around. So we only need these 4 answers to solve that one. Okay, on to our third example, like the last way that we can solve these, and this is through factoring. This one is probably less transparent just by looking at the problem. This is mainly going to occur when we have trig functions being multiplied together, and the way to separate them is to factor stuff out. So factoring works best and really can only work if we're equal to 0. So I'm going to subtract 3 cosine x from both sides to get this equal to 0. These are not like terms at all. This term is a cosine sine. This just has a cosine in it. So we're going to be left with what we started with, cosine x sine x minus 3 cosine x equals 0. Cool. All right, so now I'm going to factor. Now factoring is first looking for a greatest common factor, GCF. What does this term and this term have in common? Cosine. So we'll take a cosine out. And in our first term, we're left with just sine x. And then in our next term, we're left with just the minus 3. Cool. All right, so now what we want to do is set each factor, this one and this one, set them each to 0. Again, think about why. We're multiplying something times something, right? And we're getting 0. So if you multiply 2 things and get 0, either this first thing had to be 0 or this second thing had to be 0. Let's figure it out. So I'm going to set this to 0. So I'm going to get cosine of x equals 0. Then I'm going to set this one to 0, and I'm going to get sine of x minus 3 equals 0. And real quick, I'm going to only do this one on the interval from 0 to 2 pi. So we don't have to do all that extra plus k whatever stuff. There we go. Okay. Now, in order to solve these, this one's already basically almost solved, right? We just want to know where's the cosine 0. This one requires a little bit more. So let's first focus here. Where is our cosine 0? Well, cosines are x value. So our x value is 0 here at pi over 2. And then here at 3 pi over 2. That's it. On one time around the unit circle, that's it. So the answers here are pi over 2 and 3 pi over 2. Those are our answers down there. Let's see what kind of answers we'll get from this factor. So to solve this, I'll have to add 3. So I want to know, where is the sine of x 3? Where is sine 3? Nowhere, right? The biggest sine can be is 1. The smallest it can be is -1. So this actually does not provide any answers. I'm not going to put no solution there because we do have 2 solutions. They just weren't provided by this factor. So I'm not going to write no solution because this problem has 2 solutions. So I'm just going to say, nope, not today. So our answers are pi over 2 and 3 pi over 2. Again, because we're only working on one rotation around the unit circle, our interval is only from 0 to 2 pi. Okay, this is a you try problem. Go ahead and pause, work it out, and then hit play to check the answer. Okay, here is the solved problem. Again, this was a solving by factoring, even if, I wasn't told, and let's only work on this interval here. From 0 to 2 pi. All right, if we take a look, I first subtracted root 2 cosine x, wrote it out, set it equal, the goal was to set it equal to 0. I was able to factor out a cosine x just like before, so this problem was kind of similar to the first one. Then what we had left was right here. So we set each factor to 0 in order to solve. That's how we solve by factoring. This is the same as the previous problem. Where's the cosine 0 on our unit circle? This had a little bit of solving to do. Add root 2, divide by 2. Basically, where is the sign positive root 2 over 2? Sine is positive in the first two quadrants, since sine is our y value. So the sine is positive root 2 over 2 here at pi over 4. The sine is positive root 2 over 2 here at 3 pi over 4. And so our final answers, I'm going to write them in order around the unit circle. So first is pi over 4, that's the smallest. Then's pi over 2. Next up is 3 pi over 4. And lastly is 3 pi over 2. So that's just writing them in order. You don't have to do that. That's just when you see these types on your final, that's what they'll look like. So cool. Nice job, guys. Your assignment is next. So today you will have just 3 problems. One is going to look like the first one will look like the second example, and the last one will look like factoring. So you'll have one of each type to solve. Then tomorrow will be another virtual board work day. Here is your assignment. 3 problems again. This one looks like example 1, this one looks like example 2, and this one looks like example 3. Please note that for 1 and 2, they don't say only on the interval 0 to 2 pi, so you'll have to add a plus 2k pi or plus k pi, depending on if it's sine, cosine, or tan. Then number 14 looks like a factoring one, and it's only on the interval from 0 to 2 pi. Here's my pro tip. Have a unit circle to reference, whether it be from this video or the one that you have in your binder. All right, guys, take care and best of luck on this assignment.